In this video, we'll be going over 5 questions involving factoring and increasing difficulty. Okay, so here is the first question. It's a simple quadratic. So we know that when we're factoring, what are we first looking for? We're first looking for two numbers that multiply to this number right here, and then two numbers that add to this number right here, which is 5 and 6, just like that. So for this type of question, you could just think about it. What two number multiply to 6 and add to 5? First, so the way I do it is I just think about which numbers multiply to 6. So there's 1 and 6 and there's 2 and 3. Now 1 plus 6 wouldn't make sense here because 1 plus 6 is 7. But 2 and 3 does make sense because 2 times 3 is 6. 2 plus 3 is 5. So we can actually just write the middle term right here. Middle term 5x, we can write this as two different parts, which would be 2x and 3x, because those are the two numbers. So here I'll just do plus 2x plus 3x plus 6. Oh, don't forget your equal sign. And we can just factor by grouping, which means just factor these two separately. So for the first half, we can just factor out x. We get x plus 2. And then for the second part, we can just factor out 3. We get x plus 2. And now we have common factor, which is x plus 2. So we just factor out x plus 2. And we're left with x plus 3. And that would be our full solution. Okay, here is the second problem. Go ahead, pause the video, and try this for yourself. Now for this question, it's actually a perfect square trinomial. And let me show you how to actually check that. So for something to be a perfect square trinomial, it must meet a few criteria. First of all, the first term needs to be a perfect square. And the last term needs to be a perfect square. And there's one more thing, is the absolute value of the middle term, that which just means like if it's a negative, just ignore the negative. Middle term has to be equal to 2 times the square root of the first term times the square root of the last term. Now let's see if this trinomial meets this criteria. So for the first part, we can actually check this. So how do you know if something's a perfect square? Is if you can write it in the form something squared. So let's look at the first one. Our first term is 16x squared. We can actually write that as 4x squared. So this is a perfect square. Now what about our last term? It's 9y squared. This one right here. And we know that we can write that as 3y all squared. So it meets that. And now the last criteria. So our middle term is this right here, negative 24xy. But because we only care about the actual value and not the sign, since we're taking the absolute value, we want our 2 times the square root of the first term times square root of the last term to be equal to 24xy. And let's try this. 2 times square root of our first term is going to be 4x, because just square root of 16x squared. And then square root of our last term is going to be 3y. And that gives us 24xy. And so it meets all the criteria. Now, why do we do this? How does this help? It is because we know the formula a plus b squared is equal to a squared plus 2ab plus b squared. Or there's also a minus b squared is equal to a squared minus 2ab plus b squared. Now these formulas are very easy to derive. You can just try yourself just by expanding it. But anyways, because you know that, we can actually simplify the factoring process and help let us factor much quicker. So we know how to say a perfect square trinomial, and it's in the form of one of these two. Now, how you decide which one it is just look at this sign right here. This is a negative, therefore we're going to be looking at this one in particular. So we know that it's just going to be a minus b, or a minus b squared. That's going to be the form of which our our factored form is going to be in. So we just take the square root. We basically just take the square root of our first term here, which is just 4x. It's going to be minus, and then we take the square root of our second term here, which is going to be 3y. And that squared is your factored form. And that would be our full solution. Okay, so here is the third problem. As you can see, it's pretty short. Now you can just, of course, try this yourself, but I'll tell you right now, this is a short one. To be honest, I don't know why I put this one on third. The previous problem was definitely harder, but here you go. So anyways, our first step here is to actually notice that we have a greatest common factor between these two numbers, which is just 4. And if you factor out 4, then we get x squared minus 4. And here, we're not done, because you gotta notice we have a difference of squares in that little bracket. And if you recall the difference of squares formula, a squared minus b squared is equal to a minus b, a plus b. And just applying that formula, we get x minus 2 and then x plus 2. And that would be your full solution. Alright, so here is the fourth question. So this time it's a complex trinomial. There's a leading coefficient for x squared. So, like always, we're just looking for the two numbers that we can like decompose it as. But unlike our first question, the number that we're trying to get two numbers to multiply to is not negative 35, but rather 6 times negative 35. So in this case, 6 times negative 35 is going to be negative 210. And again, we just need to, so we want to multiply to that, and we wanted to add to 11. Two numbers that multiply to negative 210 and add to 11. So here I actually already prepared a list of few factor pairs for 210, and we can play around with the signs. We know that for every single one of these, one of them is going to have to be a negative, because we want negative 210. And if you go through this factor pairs, you look at this one. We want to add to negative 11. You notice that if you have negative 10 and 21, I'll write that down right here. Negative 10 and 21. You notice that negative 10 plus 21 is equal to 11. And negative 10 times 21 is equal to 210. So those are the two numbers that we're going to write our middle term as. So it would be 6x squared minus 10x plus 21x minus 35 is equal to, whoops, so now we factor by grouping here. 2x, it will be 3x minus 5. And then we factor out 7, giving us 3x minus 5. And now we just factor out the greatest common factor, 3x minus 5. And we're left with 2x plus 7. And that would be our final answer. But now, I know what you're thinking. How are you supposed to know all these factor pairs? Of course, nobody just knows all these factor pairs off the top of their head. You could just write a bunch down and maybe get lucky with it, but what if the numbers were much bigger? That's why there is another method. Let me write down the quadratic again. 6x squared plus 11x minus 35. Now I'm definitely going to make a more detailed video on this formula, but basically this is how it goes. We know that we have 6x squared and we want two different numbers, or coefficients of x, I should say, that we can write our 11x as, so we can group them properly. Now, there's actually a formula to find those two numbers. And the way you do it is just, you get the coefficient of that middle term, 11 in this case. What we do is we're going to divide that number by 2. And then, we are going to square that number. From there, we're going to subtract. We're going to subtract the leading coefficient of x squared and the c term. So in this case, it's going to be minus 6 times negative 35. And now once you have done all that, we're actually going to square root that number. And then at the front, when we have this value, we'll call it d. Then we actually just get half of the middle coefficient, which is in this case 11 over 2, because that's our coefficient here. And we're just going to add and subtract that whole value. So in this case, when you do this, you are going to get two numbers, and it's just going to be 21 and negative 10, which are the two numbers we use right here. So just remember this, and you should be able to factor pretty much any trinomial that is factorable. So, it's just pretty useful. Alright, so here is our final question, which is also the hardest one here for factoring. And pause the video, try for yourself, and once you've done that, we'll go over it together. So, for this one, the first thing you gotta notice is that we have two different terms that are being subtracted and are perfect squares. So of course we can just apply the difference of squares formula, which is this right here, and we just plug that in. I'm gonna use square brackets here for the big one. So we have 2x minus 3, in this case, is our a, and then our b would just be this whole thing right here, which is minus 8x squared minus 4. And now that is just being multiplied by the same thing, but when they're adding. So it's going to be 2x minus 3 plus 8x squared minus 4. And now we just simplify what's inside the big brackets. So it's going to be 2x minus 3. We distribute the negative sign. So it's going to be minus 8x squared plus 4. And then it's going to be 2x minus 3. Nothing happens for this one. 8x squared minus 4. Now simplifying, we get negative 8x squared plus 2x plus 1. And for this other one, we get 8x squared plus 2x minus 7. And now we not done here, because we need to check if either one of these are factorable, because they're clearly both just trinomials. So if we look at this right one right here, you'll actually notice that you can't factor, no matter how hard you try. But for this one, the very first thing you should be doing actually, so now this is more of a convention thing, but because we have a negative number for our leading coefficient of x, we actually need to factor that out. So we need to factor out the negative. It's just a convention thing, but it's pretty useful. So when we do that, then we get this just like that, and our right side, I'm just going to leave it because that is not factorable. And now once you've done that, you'll notice that this whole thing right here, 8x squared minus 2x minus 1, is actually factorable. And we're just looking for two numbers that multiply to this time this, which is negative 8, and add to negative 2. So we want to multiply to negative 8 and add to negative 2 right there. So what two numbers do that? Well, this, just thinking about it, you should notice that it's actually negative 4 and 2. So those are the two numbers we're going to decompose this as. So it's going to be this, minus 4x plus 2x minus 1. And I'm still going to just leave this one. Alright. And we just factor by grouping here, 4x, and then we are left with 2x minus 1. And here we just have 2x minus 1. We leave that. We still have our 8x squared plus 2x minus 7 here. There should be a bracket here. And then we just factor out the greatest common factor, 2x minus 1. And then 4x plus 1 is what we're left with. And then we just keep whatever's here, because that one wasn't factorable. 2. Bang. And that would be your final solution. that'll be it for this video, and I hope this video helped you understand how to factor all these different types of expressions, such as the difference of squares, a perfect square trinomial, or a complex trinomial. And until then, I'll see you in the next one.